there's Christian well, no. At the same time, but like not start.
All right, you should have checked the answers. We have time to go over a couple of them. Listen, I know. Let's get quiet. I know I've heard a lot of complaints about how challenging it is. Okay, it's okay. It's okay that homework's challenging. All right. Yes.
Is this like out of notes?
You know what? It's supposed to say 10.7. Okay, correct that to 10.7. Typo.
I'm very worried.
Hold on a second.
Circles in a board.
Is it circles in the coordinate plane?
Yeah.
Yep, there we go. That's where it went. Thank you. All right. Here's what I've come to learn in my math education, okay? And I've taken a lot of math classes, unfortunately. Not unfortunately. There was learning opportunities. I think I told you guys this after high school. So I took calc in high school. And then in college, I had to take like 16, 17 math classes above calculus. So I have done more hours of homework than you can ever imagine, okay? Because in college, every class is around, they call it 3 to 5 credit hours. And what the professors always say is expect to spend 2 hours outside of class for every hour you're in class. So a 5 credit hour class means you're in class for 5 hours a week and you spend 10 hours of homework a week outside of class, okay? And that was very typical. And so there would be problems that I had not even a clue what to do, all right? And what do? You have to chip away at it. You have to figure something out, try to set something up, talk to others, get things. But it's not like I could ask a professor every single day, every single problem, okay? So here's the goal, and this is what you guys should be doing in an honors math class, okay? There are going to be days where you walk in and you say, I have no idea what I did. I don't have any idea how to do that problem. That's okay. That's all right. This is an honors math class. You should be challenged sometimes, all right? But you shouldn't stay there. You shouldn't stay frustrated and complain. It's just not where you should stay mentally. That's not healthy, all right? You should ask a question on a typical problem or one that was challenging and say, okay, I can now take that and apply it to the other ones. I don't need to ask every single problem. I can ask about one of them, get an approach on how to do them, and now apply it on my own. That's the difference. In all honesty, that is one of the main differences in what we call a typical math class and an honors math classroom, is that you guys are to try to acquire and apply knowledge faster and in more depth. Okay. So that's an expectation. I'm happy to go over a couple questions with you. Okay. What are some main problems that you would like to see the approach on how to set up? 8. 8 is the first one I heard. Emma, I saw your hand as well. 8. First, what's the first thing you should be thinking of when you see number 8? Even if you have no idea how to set it up. That is an outside angle. That is an outside angle. Okay? And so here's what a good practice is in math. Before I even try to set up an equation, the measure of the outside angle is half outer arc minus inner arc. That's just the formula that I remember. Measure the angle, which is outside, is half outer arc minus inner arc. Now we're going to fill in the pieces. Do I know the angle outside? I do. In this problem, I do. What is it? 34 degrees, right? They told us it. So 34 degrees. Now being glitchy. 34 degrees is 1/2. What's my outer arc? 3x minus 2. Minus. Inner arc, am I subtracting a number or am I subtracting an expression? Because if it's an expression, I have to put parentheses. expression, right? So parentheses, what's my inner arc? X plus 6. Is that setup accurate? Well, did I use my formula for outside angles? Yeah. The angle is half outer arc minus inner arc. Okay, let's try to clean it up. This is just algebra from here on out. 1/2 3x minus 2 minus x minus 6 3x minus x is 2x. Negative 2 minus 6 is minus 8. I'm going to multiply both sides by 2 to get rid of the 1/2. So what's that, 74? Add 8. What's that, 82? Divide by 2. I get 41. Was that the answer for 8? Hold on a second. Would they ask? I didn't copy the problem. Could they ask us for an angle? Oh, a stupid mistake. All right, 68. Yeah, I do the complicated setup right, and then I double a number wrong. All right, 34. We got 68. We add 8. What do we get there? 76. Help me out. 8 to 76. And divide by 2. What's that, 38? That's better. Thanks, Jackson. Does that approach make sense to you? That's how a lot of them were. They were ugly setups, and then you had to solve using algebra. Would you like to see one more? Yes. Emma, you had the same question on that one, right? Okay, press 12. I heard 9. I can at least tell you the approach for 9. What's 9? Outside angle. What's the angle? The angle equals, what's the angle in this problem? X over 2. The angle equals 1/2 outer arc minus inner arc. And this is what I was talking about earlier. Okay, this is where you need to step in. Okay, and I'm just being honest with you. This is, some of you think when I'm like direct with you that I'm being mean. I'm not. I'm trying to help you. This is where you as honors students need to step in and say, I saw how you did the last one. This one's just like it. I can take it from here. Even if it takes getting help or reminding myself of how to solve that algebraically, I can take it from here. Do you get what I'm saying? Like, do you agree from here? It's just like the last one. Very similar. Okay. All right, that's your setup. That's how you would take it from there. Luckily, some x's are going to cancel. You're going to have just some numbers on this side. All right, Preston, you asked about number 12, right? Preston, what kind of angle is this? Outside. Outside angle. 1/2. Outer arc minus inner arc. What is my outside angle, Preston? 75. 1/2. What's my outer arc, Preston? It's 17x. Good. 17x. Minus. Now, this is probably the part that kind of tripped us up. Preston, you don't have to answer this. We can get help. Do you know what that inner arc is? We don't. But can you find it? Let's help them out, or help others out. These angles and these arcs are formed by 2 tangents. What do you notice about the red and the blue? They combine to make 360. So if they called this 17x, what's the blue arc? 360 minus that 17x arc. Whatever that 17x arc is, the blue arc is 360 minus that. If the red arc was 50, the blue would be 310. If the red arc was 100. The blue arc would be 260, right? I mean, whatever that red arc is, the blue arc is 360 minus that one. Yes? So, what goes in there? 360 minus 17x. All right, I will solve this one. 75. I would highly recommend keeping that 1/2 out until you have simplified all of the inside. That's just a good algebra practice, okay? We have 17x minus 360 plus 17x, and this is why we have 75 equals 1/2. We have 34x minus 360. I like to multiply by 2 on both sides because I know I'm trying to get x by itself. I want to get rid of stuff over there. So 150 equals 34x minus 360. Now I'm second guessing my mental math. Is that 510? Yes.
Did you distribute the negative to get positive 17x?
Yep. 510.
Yes.
Thank you. 34x equals 510. 15? X equals 15. This was number what? 12, 15.
12.
Awesome. So where did I go? There you go. This was for number 12. Preston, does that make sense? That's the kind of approach you guys need to take on those problems, okay? Now, the ones on the quiz are not going to be that challenging. They're not going to be nearly that challenging. Not. I'll be honest. I don't think they're that challenging, personally. All right? But, what's that?
I said you are a math teacher. You just said you went through like 17 classes. So it's easy for you.
Let's back up for a second. Okay? Because I think you're being a little disrespectful. I don't know if you mean to be. Are you trying to be?
No.
Okay. Here's what I think you misunderstood. I didn't say I don't think this is that challenging. Did you hear? Is that what you thought I said? Did you think I looked at this problem and I said that's not a challenging problem?
No, not that problem. You said on the quiz there's not going to be like.
They're not that challenging.
Yeah.
They're not that challenging. So what am I acknowledging? This problem was challenging. I can take 16 math classes in college and still recognize what's challenging and not challenging for you guys. Okay, I've taught this for 17 years, so I can acknowledge when you guys are going to struggle with things and when you're not. Both things can be true at the same time. All right. So, was this problem challenging, Preston? I agree. I'm glad you asked about this one. The ones on the quiz are not this challenging. However, this is a great one to do for homework. You should challenge yourself with these kind of problems. All right? Awesome. Good talk. All right. Moving on. Circles in the coordinate plane. All right. We got circles being graphed. Now, one thing I do need you guys to do, we don't have time for all the bell work, but I do want you to factor this. Okay? Some of you are not listening right now. I want you to factor numbers 3 and 4. Algebra review. Algebra review. I'll give you a hint. I don't care where you write this down. I will give you a hint. It should look like this when it's done.
No.
It's not on here. It's bell work. We're going to do it. Write it down wherever you want.
I don't know if this is right. I'm just
3 plus 3.
and then obviously first oh wait, no, because it's 3. It makes sense. So 3, right? And then last, obviously, no, okay, got it.
Because it has a equal 9, but
This is the first one right here.
I can't remember. Is it supposed to
Okay, well, first,
6
first you want to do x and x on x squared. So it's just x and x.
I mean, and then outer, right? But how long?
Outer, 3x, because outer is 6 and so 6x, so you both last.
So my brain is still kind of.
All right, let's do the first one because I hear a lot of conversations going wrong here. Jackson, question. You have an answer. Jackson, do you how did you remember the process? Like, who did you have in Algebra 1?
Mr. Spock.
And how did he teach this?
Foil?
Now, we're reverse foiling.
Oh. Yeah, he didn't teach us this. It's just kind of.
We
You what?
I don't know.
I don't even remember.
I don't really. They might have taught us it, but we just
Now we have.
Paige, I can't hear you. Sorry.
Sorry, they might have taught us it, but we probably didn't just remember how to foil.
Okay.
Yeah.
Fair. All right. If you guys don't know this, I have to give you a crash course on it.
It's so easy. It's the one thing I remember.
Who did you have?
Labyrinth.
All right, you're looking for numbers that multiply to something and add to another thing. Okay, this is the way it should have been taught. If you were taught it, I'd be shocked if you were not taught this. Okay, I would. If you think back to Algebra 1, if you were to ask any math teacher, what are some main things you learn in Algebra 1? Graphing lines, right? Equations of lines, factoring, and foiling. I mean, it is. I'm going to talk to them.
We foiled, we didn't know.
Yeah.
No, we
I
did.
would be shocked if you did that.
Yes, we did.
All right. Hey guys, we gotta go. I'm sorry. I was not planning on doing this. All right. If A is 1, even how many of you had Mrs. Naples? Okay. She would even say if A is 1, life is easy. Okay. That's exactly what she would say. I taught next door to her. I heard her say it, so I know she taught this. All right. If A is 1, life is easy. You look for a number that multiplies to this times this. Well, what's 1 times 9? We're looking for numbers that multiply to 9 and add to the center term. Add to 6. Give me numbers that multiply to 9 and add to 6. Obviously 3 and 3. 3 times 3 is 9. 3 plus 3 is 6. Now, because this is reverse foiling, we knew the first terms multiply to x squared. Remember this? If you foil, isn't this right here the f in foil? F, x squared. The other two numbers come from these numbers that multiply to 9 and add to 6. Positive 3 and positive 3. Now let's check it. Here's what's easy. I know f is going to multiply to x squared. I know L, the last terms, are going to multiply to what? 9. I just have to check the center terms. The O and the I in foil. Ready? What's x times 3? 3x plus, what's the I? 3x, and 3x plus 3x is 6x. This works. I checked it with foiling. This is called factoring. Callie.
It's always X and something and X and something, right? For foil. Like,
Do you,
like X plus or minus something and then X plus or minus something.
sometimes it could be like 3x and x.
Yeah.
Mhm.
Yeah, that's what I wrote.
I mean, it could be x and y. I mean, in later classes, you're going to do other ugly stuff. All right, over here. Now, because we have to move on, I'm not going to write out what the numbers have to multiply to and add to. Okay, but I know x and x are going to go there. If this were like a 3x squared, then it would be 3x and x. Okay, and we have to do a little bit more work. All right, we're not going to do that today. So my numbers have to multiply to 25 and add to negative 10. So they both must be negative, right? To multiply to a positive and add to a negative. They both must be negative. What are they? -5 and -5. Now, there's another way to write this. X minus 5 quantity squared and x plus 3 quantity squared. That's going to be very important for today's lesson. All right? Very important.
Are we doing that on the 26th?
Yes. Yes. All right. Now, a quick little refresher. Do you remember the distance formula? All right. I'm going to... I don't have time to really talk about this as much as I want to, which some of you are relieved by. I'm going to get rid of this circle for a second. Way back in chapter, I think it was 1, we would find the distance, all eyes up here, we would find the distance from this point to this point using the distance formula. Today, we're doing the same thing, only we're calling it the radius of some circle. Okay? And instead of x1, y1, and x2, y2, we're using the point h, comma, k. H, comma, k from today till forever, until the end of your math career. H and k are the x and the y values of the center of a circle. The center of a circle. And any point on the outside are just some general x, comma, y. The distance from the center to any point on the circle is called a radius, correct? And we can use the distance formula to get there. Here's how it works. X minus h squared plus y minus k squared equals r squared, equals r. The square root of that equals r. Do you agree to get rid of the square root? I would have to square both sides. What happens when you square this square root? It goes away. What happens when you square r? You get r squared. So this came from the distance formula. And it's called the general form or the equation of a circle. The equation of a circle with the center h, comma, k and radius r is x minus h squared plus y minus k squared equals r squared. That is the equation of a circle. You have to know that. Olivia.
At the end of like the r squared equals all that, are you gonna square root that?
No, what I boxed in red is the actual one we're going to use. I just showed you where it came from.
So we're gonna answer that.
We're going to do a lot with that. Yes. Now, if I asked you, what's the equation of a line? I hope you would say like y equals mx plus b. Or point slope form. Y minus y1 equals m times x minus x1. Those are two accepted forms of a line. Do you agree? Equation of a line. Y equals mx plus b. Yes? This is the same kind of thing, only it's the equation of a circle. It's x minus h squared plus y minus k squared equals r squared. And it came from the distance formula. Why? Because the way I would define a circle is it's the same. Remember our definition at the beginning of the chapter? It's the set of all points, the same distance from the center, right? Well, what's the distance from the center? The radius. Oh, it's defined by its radius and its center. If you need to graph a circle on graph paper, all you need to know is the center and the radius, and you can graph it. The center is HK, and the radius is R. Now, do you notice how the formula has subtraction in it? It has subtraction in it because of the distance formula, but you have to be careful. What if H is 2 and K is 5? It's going to be X minus 2 and Y minus 5, right? Because of the formula having subtraction in it, they're going to appear to be opposites of what they actually are. All right, now we're just going to write the equation of a circle. And this is circle J with the center 2, 2 and radius 4. All we have to do is write the equation. Just like when we wrote equations of lines, if I gave you the slope and the y-intercept, you plug the slope in for M, you plug the y-intercept in for B, and you have your equation. Same thing. So if you're a template person, you're going to like to do this. X minus something squared plus y minus something squared equals something squared, r squared, right? H goes here, K goes here, R goes here. Here's your template if you like to memorize a formula to do the same thing every time. All right, what goes in our first set of parentheses? X minus 2, y minus 2, and what's getting squared? 4. Yeah, I would like for you to say x minus 2 squared plus y minus 2 squared equals 16. Okay, you're just going to square the radius and write that number. That is the equation of the circle. Done. Don't FOIL it out. Don't do x minus 2 times x minus 2 and FOIL it out. That would no longer be the equation of a circle. This is my answer. Now, be able to go backwards. What if I give you this equation and I say, what was the center? What's the radius? This is what I was talking about in the last slide. Isn't it the opposite sign of negative 2, right? The equation had minus in it. So wasn't the h value positive 2 and the k value positive 2? And don't look at the 16. It's not 16. It's the square root of 16. Okay, it's 4. All right, try the next one on your own. All right, that should be your final answer. X minus 0. Don't leave it as x minus 0. It's just x. And when you square x, you get x squared. And don't leave minus a negative. Go ahead and make that a plus. Y plus 3 squared, and then that's 64. Make sense? That would be my final answer. Now, could you graph that? I would do the center first. 0, negative 3. Yes? 0, negative 3. Count up 8, down 8, left 8, right 8, and just kind of make a circle. All right. Now, we have circle K, circle K, that passes through 6, 4, and has a center 1, negative 8. What's the difference here? What's different about this one? Christian.
It has a center, like not just.
Yeah, they gave us a center, and what else? What are we missing?
It passes through J.
Yeah, so what are we missing in this problem?
Radius.
Yeah, so here's what I can do. I can say, okay, center, okay, H, K. I can do that part. I could write x minus 1 squared plus y plus 8 squared. But I don't have the r, do I? All right, so we're going to find the length of the radius. That's the only part we're missing. Because right now, here's what we have. We have x minus 1 squared plus, I'm not going to write y minus a negative 8. I'm just going to put plus 8. I need the r. I need the r. How should I find r? Okay.
Can we put the 6 and 4 for the x and y?
Ooh, I kind of like that. That wasn't how I was going to plan to do it.
There's a more complicated way.
Any other ideas? She said put the other x and y in for here. That's what you meant, right?
Mhm.
And call this r and solve for r. We might do it the Olivia way. What's another way to do it? Well, how do you find? I heard someone say it. How do you find how far these 2 points are away from each other? Because isn't that the radius? If I say I have the center, watch up here for a second. I have the center, and I have some point on the circle. What's the radius?
The distance between.
It's the distance between them. Using the distance formula, right? Using the distance formula. I'm going to give you 2 options, okay? So the distance formula, I remember how we called it d equals the square root of x2 minus x1 squared plus y2. Remember that? Here, it's actually the length we're finding is called the radius, right? So I'm fine if you do it either way. I'm going to give you the option. The radius is, well, the 2 points we're going to use are j and k. So let's do 1 minus 6 squared. Actually, to show you Olivia's way, I'm going to actually do this. I'm going to subtract them the other way. So I'm going to call this x2, y2 and x1, y1 back in the distance formula. We're going to do 6 minus 1 squared plus 4 minus negative 8 squared plus 2. What's 6 minus 1 squared? 4 minus a negative 8 squared. Good. So r is the square root of 169, which is 13. So what goes in here? 13 squared. So our final answer is going to be x minus 1 squared plus y plus 8 squared equals 169. Did that make sense? To find the radius, to find the distance between the 2 points. All right, should we do the Olivia method? Something I never thought I would say this year. Just kidding. That's actually very, very good, Olivia. All right, Olivia is saying, here, pretend this 13 isn't here. Okay, r is 13. She's saying if this is r squared, couldn't we plug in, didn't we already plug in the center? Didn't we already plug in h and k into this? Right? Wasn't this h and wasn't this a part of k? Yes? She's saying, what if we took the other point, 6, 4, plugged 6 in for x and 4 in for y and solve, well, I'm not even going to say solve for r because I'll show you what's going to work out pretty neatly here. What's 6 minus 1 squared? Plus 144. What's 25 plus 144? And I'm not even going to square root. Why not? Because we want r squared, don't we? We want r squared, and r squared is 169. Deserves a high five. I like it. Do you have a preference? How many of you prefer to do it that way? Olivia. Brilliant.
Thank you. I'm so proud of you.
Brilliant. All right. Now, can I give you guys a word of warning where I've seen this go wrong? And I'm not saying this method. I'm saying like point slope form back in lines. Students start plugging in numbers. Hear me very, very clearly. Students start plugging in numbers and think that like this is what the final answer is going to be with all the numbers plugged in. That's not an equation for a circle. An equation of a circle, you should be able to plug in any x, y that's on the circle, and it would work out. That's only one x, y that's been plugged in to work out. Make sense? Awesome. So what's our answer? Our answer is this equation. All right. Try this one on your own. Wow, we're not even close to getting through this lesson. All right, try this one on your own. I'm going to narrow down the homework.
Oh, we were talking about this.
No, you asked your, you had you're not.
Did you guys get this?
Yeah.
Questions on what we've learned today? All right. So the homework is going to be narrowed down. We're not going to do 7 through 18 all. We're going to do 2 through 6 even, and 7 through 12 all today. Everybody see that adjustment? Instead of 7 through 18, 7 through 12 all. 2 through 6 even. That's 2, 4, and 6 for those of you who don't like evens. And then 7, 8, 9, 10, 11, 12.
That's not gonna go.